All right, so hopefully linear proofs are hunky-dory, peachy keen, coolio. Who's absent? Nobody. Yay. I love taking attendance in this class. Uh-oh. How many of my young pupils? Right. Does your proof look a little something like that? Yes? Yes, yes? Okay, cool. Now, today you're doing curves. Why is curve different? Well, when you have linear, it's easy because if you take an equal gap on either side in x, it'll make an equal gap on either side in y. These two are symmetric. It's pretty clean. But if you were to do a curve, if you take a gap of 1 inch on either side of x, whatever that is, it's about the same, you actually get a very different y gap because of the curve issue, all right? Now, because of that, you're actually going to have to choose a delta between two choices. Things get a little more complicated. So, here we go. This, proving nonlinear, will involve a little maddening two-step, okay? You're going to be, if you're just like everybody who's ever learned this, including me, that they learned this, I just did this. What am I, just writing everything in reverse? Yes, you're writing everything in your reverse, right? It's just like your teacher doesn't see your rough draft, all right? So it feels like, yeah, you're writing the same paper twice, but they don't see a rough draft. All they see is the final product. The same will go here. You'll do some scratch work to get your delta, but then you're going to do a formal proof, and people won't see that scratch work, all right? Now, here's the process. You're trying to prove that the limit as x goes to 3 of x squared equals 9. It doesn't say find the limit. That's easy. Prove the limit is 9. That's harder. The first thing you have to do is go to your scratch paper to find the delta. Now, on tests and homework, I don't want to see this one. I don't care. I don't, wherever you do it, if you do it on your hand, whatever. I don't care. Okay? You won't turn this in. Now, for the sake of notes, however, you probably need to see it so you can have this as a reference. So today only you're going to have your scratch paper on this. You with me? Now you find delta by actually going backwards from f minus l towards x minus c. So in this case, if you start with x squared minus 9, needs to end as less than epsilon, I want to work backwards towards what would I have to get x around 3 to be, and that, this, once I get backwards to x minus 3, this will be my delta. All right. So I want to go from the function minus 1 back to what x has to be. Now, every problem in nonlinear is different. It's not like linear where it's always the same epsilon over the slope. Each one has its own challenges. This, how could you get from x squared minus 9 and change it a little to get to x minus 3? You could factor, okay? So you could factor this into x plus 3, x minus 3. True, all right? Now you could isolate x minus 3 by dividing. Now as we go, understand the importance of absolute value. Remember, when you're dealing with inequalities, it's not just like an equation, because there's that gray area of when you divide by a negative, you switch the sign, but when you divide by a positive, you don't. And so it's important that you have that absolute value on there, because that eliminates that, should I switch the sign or should I not? Kind of, you follow? Now this seems like students want to say, well, there's my delta. Boom. That's not delta. Delta must be numerical. Epsilon numerical, not a function of x, not dependent on x. So we need a numerical delta. So what is a numerical form of x plus 3? This is where this step bothers students the first time they see it. But because we are interested in x close to 3 in this problem, let's assume x is close. Let's assume x is close to 3. Right? Now, close to 3 could mean a lot of things. What does that mean? Within 1, within 2. Generally speaking, most people say it's fair to assume that, let's just assume x is within 1 unit of 3 on either side. So let's assume that because we're looking at as x goes to 3, x is in the 2 to 4. Now, that's a fair assumption. That's not breaking any math. That is allowed in common. Okay? Now my goal is to not get x, but what does x plus 3, absolute value in the denominator, look like numerically? So now I'm going to try and change this to look like that. Need more room here. All right. Now we'll do this in steps, but this scratch work will be done pretty quickly once you get good at these, because nobody's going to see it anyway. It's for your benefit, right? So I could definitely, rules of inequalities say that if this is true, 2 is less than x is less than 4, then if I add 3 to each piece, it should stay that same order. Adding 3 to each part doesn't change the inequality, right? Now, I think you'll also agree that because x plus 3 is between 5 and 7, it's got to be positive, right? So is there any reason I couldn't slap an absolute value on it? I mean, to the reader, that may think, like, sure, whatever, what a waste of time. But yeah, it is positive, and so there's no change there. Now, this guy, this might be a little new to you, but it's accepted to anybody reading your proof. Assume you looked at 3 numbers, 3 whole numbers, and an inequality that was true. Do you agree 3 is less than 4 is less than 5? When you take reciprocals, is the inequality the same direction, or does it switch directions? In other words, 1/3, 1/4, and 1/5. Now, which is the greatest? Yeah, 1/3 is the greatest of those 2. Now, when you take positive numbers now, positives, if you have positives and you switch the inequalities, or switch the fractions, then the inequalities switch directions. That is an accepted fact of math. It's positive, switching, or reciprocals switch the inequalities. Okay, last but not least, I want to get a delta in here. Now remember this whole idea, or part of the definition of a limit is f minus L is less than epsilon. Now, wouldn't you agree that absolute value is always positive? Or at least 0, yeah? So if epsilon is greater than a positive number, doesn't epsilon have to be a positive number? Okay, and it's accepted that epsilon is a positive number. Epsilon is always positive. It's like a distance around the x, and so it's because it's a distance, it's positive. So if I multiply Drew by epsilon, we're all cool. Now that right there is your choice on your delta. And you always choose the lesser for delta. And so in this case, you're going to say delta is epsilon over 7. Now that's the end of your scratch. That's what you need to make your proof. All right. So I did my scratch work. Now I'm ready to begin the proof. Just like yesterday, we start by identifying delta. Let delta equal epsilon over 7. Now think about this for a second. I'm not going to see your scratch work. I'm going to be thinking, epsilon over 7, where are you getting it? You're going to need to communicate where you're getting it, right? So you say, oh, hang on just a second. I'll show you why epsilon over 7. Start with the thesis to your proof. You're going to show that if x is within, I forgot what I was actually proving. Oh yeah, x is within delta of 3, or the difference between x and 3 is within that delta, then it must follow that the y values, or f values, will be arbitrarily small to the limit. We can get as close to the limit as you want in a case. You follow? All right. Now we start by assuming x minus 3 is less than delta. If we take x's within that delta away from 3, then that would also imply that x minus 3 is less than epsilon over 7. Now to the reader, this is where the payoff is. Now it's where you're going to have to show, all right, now this is where epsilon over 7 comes from. You go off to the side, think of it as like a corollary, side note, okay? You're going to show some of this thinking, but not all. Start with the assumption that x is close to 3. And that is to say, let's assume that x is within 1 unit of 3 on either side, between 2 and 4. Cool? Now remember, this is new to them. They haven't seen your stuff. So they're following you and say, okay, we're talking about a limit as close to 3, so that's cool. Now, you're going to show where the epsilon over 7 comes from. Now, that's going to be redoing a lot of this work, and that's the part that takes students off. I'm going to write it all again. I don't see this. I see this. So, yeah, you have to write it again. If we add 3 to each side, okay, I'm with you. I can see that. I can add 3 to each piece in the inequality flow. That's with you with me. And then, what should I do? Absolute value. Okay, you can put some absolute value on it, whatever. Okay, then what? Yes. Yeah. Now, let me say this. I'll say this over and over again. This, I don't give a rip how fast you go. But this, somebody's following you to your house, okay? It's your job to not lose them, just peel out and leave them in the dust. You're trying to say, okay, don't stay with me now, stay with me. It's your goal to be as slow and as clear as possible, right? So don't burn through the red light and leave them all right? So if I take a reciprocal, now the good news is that you don't have to write justifications next to each of these steps. You don't have to say, because the reciprocal of positive numbers results in an opposite. You don't have to say all that, thankfully. You're assuming that the reader does have some math knowledge. And finally, epsilon over 5 is greater than epsilon over the absolute value of x plus 3 is greater than epsilon over 7. Checkity check. Now here's where the beautiful logic comes in. Go back to your proof. Now we just left off saying that x minus 3 is less than epsilon over 7. But I also just showed that epsilon over 7 is less than epsilon over x plus 3. Right? The first part is from the previous step. This part is from that which we just proved. X plus 3 is greater than epsilon over 7. Now, if A is less than B is less than C, then A is less than C. And we can say that x minus 3, therefore, must be less than epsilon over x plus 3. Now, at that point, the epsilon over 7, it served its purpose. And now it's trying to get the x squared minus 9. That's why that epsilon over x plus 3 is the main star of the show now. We move back over. We multiply. And boom, that is what we're trying to prove. Quoad demonstratum. Yeah? 3D, as you often see in proofs. Okay. Now that's what it's looking like. Are you ready to try it on your own? Yes, you are. Go. Now, here, if you want to use the scratch paper, fine. If you want to have it on here, fine. Just know that on the homework, I will not be looking at your scratch work to find out. Okay? Give it a go and talk it over with your math amigos. Keep in mind the scratch work is for your benefit, so if you skip a step here and there, that's fine. And know yourself. If you mess up, if you skip steps, then don't do it. your delta yet? What's your delta? So number 6 is good. Go on. General rule of thumb, by the way, for a proof is unless they're really minuscule steps, you don't do anything more than one thing per step. So people reading it say, I don't have to think, oh, he did this, and he did this, and he did this. It should be one change per step in the proof part. How's it going? Okay, is that about what your work looks like?
Yeah.
All right, now, I said linear, it's all pretty much the same, always the same. Every curve is different. And so the algebra especially involved will differ. So these were both parabolas, so they look the same. But go to the back, this will be different. Let's walk through two other kind of wacky ones, and you'll have a pretty good picture of some. You won't have seen everything, but it's a pretty good start. Okay? Proving this. First of all, verify that the limit is correct. Do you agree? Because if you try to prove something that's not true, it will fall. All right. Let's find our delta off to the side. Where should I start? Or on your scratch paper, whatever. I don't care where you do. Where should I start? 1 over x minus 1/4 is less than epsilon. And my goal being to get to x minus 4 is less than something, right? All right. So, algebra. What did I do? Can I flippity flip? I warned you about when you have a difference of fractions, you cannot flip, right? So what do you have to do? Common denominator. You should get a common denominator. You should not flippity flip. Now we're starting to get somewhere. I'm seeing that x minus 4 happen, sort of. What should we do next? What do you want? You want x minus 4, right? So what would it make sense to move? The 4x, okay. So 4 minus x is less than epsilon 4x. Now what about that 4 minus x, not x minus 4? Does order matter in subtraction when there isn't absolute value? Well, yeah, a lot. But does order matter in subtraction when there is absolute value? No, it's a non-issue. So this is x minus 4. It's all good because the absolute value. All right, so is that my delta, epsilon 4x? No, it needs to be numerical. So this is where we go to assuming that x is within a unit on either side of 4. So we're assuming that x is between 3 and 5. So then what? Multiply by 4. So 4x is between 12 and 20, and then bring in an epsilon, and we'll work out the absolute value and all that stuff in our formal proof. But I'm feeling something like that. So what is our note? Choose the lesser of the two. Don't think it's on the right or the left. Choose the lesser, and so 12 epsilon is the lesser, okay? So you're going to let delta equal 12 epsilon. And the reader, remember, doesn't see your scratch work. They're waiting for you to show how 12 epsilon comes up. So you're going to first state, you're basically going to say, this is the definition of a limit. I'm going to meet the definition's criteria. I will show that if x is within delta of 4 on either side, then it must follow that y or f will be within epsilon of 1/4. It has to follow, like dominoes. All right? So let's assume that we push over the first domino. X minus 4 is less than 12. X minus 4 then must be also less than 12 epsilon by our definition. Side note, by 12 epsilon. So assume x is close to 4. So let's go within 3 and 4. I understand it's tedious to write the same thing over again, but again, it's final draft rough draft. 4x. Now I am going to show an absolute value being slapped on there, which I can do because if it's between 12 and 20, obviously it's positive, and absolute value is positive, so it isn't changing anything. And then multiplying by epsilon is multiplying by a non-zero quantity, so that is also allowed, and it's not negative, so no worries. All right, so once you get to that step, that's what allows you to come back and show the A is less than B is less than C step. I know from previous work that A, x minus 4, is less than B, 12 epsilon. But I also just showed that B, 12 epsilon, is less than C, 4x epsilon. Okay? And therefore A must be less than C. X minus 4's absolute value must be less than 4x epsilon. Now here's where undoing that algebra, that's a bit of a careful act. You need to do it slowly. Students are tempted to just say, ah, there you go. There's still 3 steps to go. I would show, hey, single absolute values, all good. Then how am I going to break it up, or, oh darn it, I just told you. How am I going to get back to 1 over, or f of, well, you know what do I do? Yeah. Wish I could speak. X over 4x minus 4 over 4x is less than epsilon. Now that reduces to 1 over 4 minus 1 over x. Am I done now? Doggone it, no, that's not f of x minus L. But can I switch the order? Is it okay to say that's the same as 1 over x minus 1/4? Well, yeah, because the absolute value, that's okay to say. And that is f of x minus L. Boom. All right. The ugliest that you'll see, and if you go to be a math major, you'll do these with sine and transcendental functions. They're considerably harder. Negatives are also a little harder. But the hardest you'll see is something like this. You'll see over the course of this problem that your x is actually going to have a couple bounds here. Start it off, and I'll follow behind you, and we'll talk about the icky part. But would you try and find the delta here? Ha! Knew it. It was wrong. It's 2x. They said you double it, and that's bogus. I knew it was bogus. It was liars. Okay, are you at something like x squared plus 2x plus 4? All right. So now you're trying to bound that. Now the problem with that is that it has 2x terms, right? This is the idea that you're going to want to use in such a case. If you have 2x terms or more, this is an accepted truth of trichotomy. Imagine you had two inequalities. 1 is less than 2 is less than 3. I think you'll agree that's true. 4 is less than 5 is less than 6. I think you'll agree that's true. If you were to add the lesser of the bunch, the middle of the bunch, and the greatest of the bunch, you would get an equality that is also true. 5 is less than 7 is less than 9. Now that said then, that's what you're going to use here. Assume that x is within a unit on either side of 2. So x is between 1 and 3, right? Now that would imply two things. First of all, that x squared would be between 1 and 9, and that 2x would be between 2 and 6. So x squared plus 2x must be between 3 and 15. Right? Now the 4 we can slap in also. If I then add in the 4, x squared plus 2x plus 4, then that leaves me with x squared plus 2x plus 4 has to be between 7 and 19. And so if we throw an epsilon in there, then delta is 7 epsilon or 19 epsilon? Actually, I'm not ready yet because what's wrong with that? Yeah, the absolute value is an issue, but the bigger issue is the denominator, yeah? Doesn't that mean that, oops, the epsilon's too early. We need to flip them first, right? So 1/7 is greater than 1 over x squared plus 2x plus 4 is greater than 1/19. So I'm going to let my delta equal what? Epsilon over 7 or epsilon over 9? 19, that's right, 19. The lesser is epsilon over 19. Cool? All right, so now we're ready to write our proof. I doubt we'll have time to finish it, but we did the hard part. After that, it's just kind of reversing the process. Let delta equal epsilon over 19. I will show if x is within a delta of 2, then it must follow that y is within an epsilon of 9, or f. The difference between f and the limit is less than epsilon. And then you start knocking over dominators. Are you tracking? All right. If you want to crank that out, I have 4 people stay. It's gotta finish. Cool. Good for you. I love you. Good one. I forgot to put the key to 102 online, so I'll put the key to 102 and 103 online, and we'll get caught up tomorrow. Okay? Have a lovely day. Now you are a delta epsilon master.